Yes.
So pointers is the best feature of the C language. You can do almost everything using pointers, but it's still one of the most difficult concepts to understand with the C code, because other languages, well, they use pointers and memory addresses, but not in that low level way.
Okay.
And when I first started learning pointers, uh, I found it to be quite difficult. I didn't understand it the first time I tried, and it took a couple of tries, so to say.
Mhm.
So don't feel that you have to understand everything I say today, and I will use pointers in many different lectures, so
Okay.
you will get the hang of it after a while, I think.
Okay.
So let's see. I need to connect to the right server and to the right screen. There we go. All right, so let's see, where did I put this stuff? Course T lesson 2. All right, there we go. So before I begin, I want to tell you a little bit about how the memory works
Mhm.
in C. So when you start your program, the operating system will set up the process and its memory, and it's structured in a specific way, and every part of the program's memory will have an address, a unique address.
Yes.
So they might look something like this, like a big hex number.
Mhm.
And an example would be if I run a hex dump against the ls command. Let's
Mm.
do -c. So to the left, you can think of these as memory addresses. They look pretty
Okay.
much the same. So in this case, this is memory address 140 in hex, which means that this character will have that address. And this will be 141, 142, etc.
Okay.
Um, and a pointer is basically a 4 or 8 byte variable, depending on how many bits you have in your CPU. So nowadays it's
Okay.
mostly 64 bits, um, which means that the pointer is declared pretty much like a regular variable, like this. The only difference is the star before the variable name, and that means that this will hold one memory address, pointing towards a char array in this case.
A chart array.
Yes, in this case.
Okay. Yeah, that's another way of declaring a char array, right? With a pointer
Yes, you can
syntax.
do something like char p equals hello, for example.
Yeah. Yeah.
And that means that this string will be uh, put inside of the memory,
Mhm.
and this pointer will point towards that memory address.
Mhm.
So let's talk a little bit more about how the memory is structured.
So just want to ask something. You did
Yes,
this command hex dump against the LCX binary.
yeah.
So does this mean it actually loaded the LC binary in memory and then showed us this, or or
Um, Well, kinda. It basically just opened the file and presented it in a certain way. The
Okay,
actual memory addresses will be different.
different. Okay,
Yeah.
okay, okay.
So you can, for example, run the command, let's see, read elf, because elf is the file format for executables in Linux. Maybe you know that already.
Mm-hmm.
And then you can add the header command and run it against any binary. And then you will see the first real memory address that where the
Yeah.
program starts.
Okay.
So this is like the main function.
Mm-hmm.
Um, all right. So the memory is set up in different sections, which have different purposes. So in the bottom, at the highest memory addresses, we have a section called data, and they're usually specified with a dot in front of it. And data is what it sounds like. It's all the static strings, for example. So in our last example, we did hello, and that
Yeah.
will say yes,
When you declare a string like that, you cannot modify it afterwards, right?
exactly. And that
Yeah.
is
So
what,
that's why it's yeah. Okay.
and that is because it's inside of this data segment, which is regularly, most of the time anyway, it's read only and not executable.
Okay.
So this is basically for all the static strings in your program, which never changes.
Mm-hmm. All the constant variables.
Exactly. Or rather, they're the thing inside of them.
Okay.
Then we have the BSS section, which is uninitialized data. So if you, for example, declare a global variable like this outside
Do
of
we
your
have static
function,
in C? Do we have static?
we do, but it
Okay.
has a little bit different meaning than if you define it in a class
Okay.
in other languages. Basically, if you I forgot the char. So if you define it like this, it will be a regular global variable
Mm-hmm.
in your program. But if you define it with static, it will be put inside of this
Mm-hmm.
BSS part of your program.
Okay. Okay.
Um, and that basically means that even if you were to put this inside of a function like this,
Mm-hmm.
after the function has terminated, let's say
It
you
won't
define
be
it,
collected.
sorry,
It won't be garbage collected.
exactly. Like if
Okay.
you define it like you regularly do, it will be garbage collected, but not if you define it set, which
Okay.
means you can, for example, return this thing if you have a different way of declaring this function like this. Then
Mm-hmm.
you can return this string. That's not possible unless you save it in a part of the memory that other functions may access.
Oh, so if you don't declare it as static, you cannot return it?
No,
Oh, okay.
you can, however, if this were an int, for example.
Integer. Yeah. With int, I know, and even with struct, I know that you can do it because I did it in the bank application program.
Yeah, because if you do it like this, it will not return the address of the variable. It will return the actual value of the
Yes.
variable.
Yes.
But when you
Okay.
are dealing with strings, arrays, or pointers, you need to think where it's saved in memory so you can return it properly.
Mm. Okay.
Um, but if you make a static string, for example, like this, let's redefine this one. Um, you can call it from another function as usual, like if you have a char pointer that you want to be returned from this function.
Hmm.
But let's say you have, what if you have like another function, let's call it function 2, which takes two arguments, and you send this to both, like two instances of this. And in this
Hmm.
case, this will return the same. But let's pretend that we send some variable as an argument to this function, and that makes it return different things.
Hmm.
Then you're a little bit in trouble, since this is only one place in memory. If you call it
Yes,
twice, it will not create two instances of this variable.
it will return the same thing.
Yes, it will. Even though if you wanted to return something based on these variables, it will
Okay.
return the same thing. So you need to be careful when doing it this way. If you only are going to use it by like one instance at a time, then it's perfect to do this, but not always.
Hmm. Okay.
Um, then we have the text segment, which is your code. Let me just do this. And this part of the memory is read write, and the code part is read executable.
Hmm.
And I don't know why it's called text, but this is the machine code of your program.
Hmm.
So, for example, in the tool that I am building, runlock, I will make use of this, but I will modify it so it's writable as well. So you can do things like that, and then I can self-modify my code inside memory.
Hmm.
But the default setting is it's only read and executable. Okay, so these are the basic parts of that part of the memory, and then we have two others, which
Sorry.
are
So this is so this is within this is a subset of the memory which is allocated to our program, and it contains these sections.
correct,
Okay.
and they are
Every
not
time we
only
run a program, we have these sections in the subset of the memory allocated for our program.
exactly.
Okay.
Um, and they are not always in the same order that I have shown here. That is optional.
Mhm.
But those two that I'm going to talk about now, they are always on the top, so to speak.
Okay.
So this is usually a pretty small part of the memory. And then we have the rest of the memory, which is divided in two things. We have the heap
And the stack, I think.
and the stack. Exactly. So the heap is dynamically allocated memory. And this is regularly write and read or read and write. And then we have the stack, and you know about the stack, I think.
No, no.
Uh, Okay, the stack
I know
is
what it's
used.
called.
The stack is being used for um, local variables inside of functions,
Mhm,
uh, and it's read and write. And then we have something in between, which is called the break,
mhm,
because this part of the memory is defined, its size is defined when you start the program.
mhm,
But the stack and the heap uh, changes.
mhm,
So from the beginning, the heap is pretty empty, and the stack as well. Then you call a function, and the stack grows, which means that the break line will be moved downwards towards the heap. So let's say the heap is, I'm not sure how I'm going to represent it, but let's say we have allocated some memory on the heap, and and these are the stars, the allocations, and then we have the dots above that, which is empty, nothing,
mhm,
and they go all the way up to the stack. And when you call functions, these will be replaced with the variables data.
mhm.
And this break line uh, will change when we allocate the dynamic memory on the heap.
Mhm.
So basically, if we need more space, we move up the break line and intrude on the possible stack, so to
Stack.
speak. But these are a lot of memory between here. So they usually don't collide because there
Mhm,
is very much room, like gigabytes and gigabytes of data.
mhm.
Um, all right. So that's basically how it's defined. And in order to get memory from the heap, you usually use the malloc function,
Mhm,
and you tell it how much memory you need, and it will return an address to the first byte of that memory block.
mhm,
While the stack has a fixed size for each function. So if you have
mhm,
like, let's say you have a function that calls another function that calls a third function,
mhm.
then all of these three will allocate memory on the stack. So the stack grows when you do function calls. And when the
And it
function
also
returns,
preserves the order, I think.
sorry,
It was so. Is this the same thing that, for example, when I'm debugging or when something where when an error happens, we get a call stack. Is this the same thing?
yes, it's exactly the same
Okay.
thing.
Okay. Yeah.
So when you call a function, the stack grows with the local variables of that function. And when the function returns, the stack will be smaller.
Mhm. So it is there is a data structure that I think the stack uh, works. Is it called the stack? Maybe.
Yes, it's called the stack.
Okay.
Um, and
First in,
yes,
first out, something like that. No, or
exactly.
no. Mm.
So there are two stack operations if you go deep into it, push
Push
and
and
pop.
pop.
Yeah. So if you push like a number, that number will be placed on the stack.
Mhm.
And if you push a second number, uh, that
Yeah,
too
it
will be placed on the
stacks
stack.
on top of it. Yeah.
Exactly.
Okay.
So it grows uh, that way. And when you pop something, like pop EBX, I'm going to talk more about these registers later on.
Hmm.
But
Okay.
this will take the data on top of the stack, remove it from the stack, and put it inside of this EBX
Register.
variable, or well,
Okay.
it's like a variable.
Okay.
So that is how the stack works under the hood. But C
Mm.
handles everything for you.
Okay.
The only thing you need to do is declare your variables in the function, and it will take care of the stack.
Hmm.
The heap, however, you need to run on your own. And that
Hmm.
is one thing which separates C from almost all other languages. Because in most languages, you simply create an object, right?
Yeah.
And when you do that, it will check how big this object is, and it will automatically allocate that size from the memory.
Yes.
But in C, you need to do that manually. So let's say you want to put a struct on the stack, on the heap, I mean, with two integers. So this will be an 8-byte structure, 4 for
Hmm.
each integer.
Yeah.
Then you will call mala 8, and you will
Yes.
receive 8 bytes of memory.
Hmm.
So you can store
Hmm.
this inside of the heap. And when you're done with it, you call free and the name of the variable. And this will be removed, and the break line might move as well.
Hmm. So why
Okay.
does you say this separates C from almost all other languages? You mean it in a way that it is one of the few languages that allows you to manage the memory yourself? Is this a positive? Is this a negative?
I think it's a positive. I think this is the biggest unique selling point for the C language.
Okay.
Uh, it makes the language pretty difficult, and
Hmm.
if you don't know what you're doing, it's very possible that you will introduce serious bugs into the program.
Hmm.
Uh, However, if you do know what you're doing, then you have unique possibilities
Hmm.
to create programs.
Okay. Because of this feature.
Yeah, so because
Okay.
C is, if you compare C with C++, for example, C++
Hmm.
has a lot of functions and different commands and a lot of things. But
Hmm.
C aims to have as few commands as possible,
Hmm.
but instead give full control to the programmer. So if you
Hmm.
combine all of these few commands, you can basically write everything which is possible to program on a computer.
Hmm.
So the basic building blocks will create anything, and that is why people like C.
Hmm.
Uh, okay, so that's about the memory. I will save this notes in a text file that I can give to you afterwards.
Hmm.
So let's do an example program when we try out pointers. I'll simply include the standard IO and create a main function. And let's create a regular string first and copy something into it. And I usually use this command when I want to put something inside of a string.
Yeah. You cannot. Yeah. I also noticed this. we went through this function on the last lesson, but like when you gonna get used to assigning the integers and assigning stuff like that, and then you try to assign a string, and then you get a I don't know. That was I don't know what the compiler was saying, but it basically didn't let you assign a string this way when you declare the char string with the array side.
Yeah, that's true. Because this is not a regular value stored inside of a variable. Uh, if we go under the hood for this array, for example, it's actually the str is actually a pointer, but
Hmm.
behaves a little bit
We will
different.
go. Okay, we will go
So
through it later.
you need to either take one byte at a time and set that to whatever you uh,
Hmm.
feel like,
Hmm. Yeah,
uh, or you call this function which does it for you.
yeah.
So it basically iterates through this and puts it inside of this array. Uh, and I also, if I declare it this to be 32, I always make this 31. So this is the upper limit of characters that we want to copy.
Hmm.
Because you always need to be careful not to overflow these variables. Because if you do, a hacker might exploit your code.
Hmm.
And recently I've seen that when you do it like this, the compiler will give you a warning that this string might be cut because it might not fit inside of this, even
Hmm.
though these are like 10 characters and this is 31. So that is an annoying message,
Feature.
which I don't think is necessary
Hmm.
because I think this is a security thing. I want this to be 1 byte less than the actual size.
Yeah.
So I usually just suppress that warning or ignore it. All right. Uh, by the way, let's put this back. Um, this should be removed though. All right, so we have a string. Uh, let's just print the string for now.
You need to put the string that you will print.
That's right. Good. You are awake. So let's see. I'll create an additional window. And where were we? We were inside of course the lesson 2. I'll set this to my home base. Let's see. And we'll compile this stuff. Uh, all right. I forgot to include.
String header. Yeah.
Yeah. And as we know, this will just print this to the screen.
Hmm.
Um, let's create a pointer. So we create a pointer the same way we create regular variables. The only difference is we put a star in front of the name.
Hmm.
So let's call this P. And let's do P equals str. And when dealing with pointers, this is not an assignment. We are not uh, putting this
It's fine.
string or its value inside of P.
Hmm.
So the equal sign is a little bit,
Confusing.
yeah. I would like something like P arrow
Hmm.
str. or something like that, because that is what it is. When we run this command, the P will be
We point.
pointing towards SDR.
Mhm.
Like everything in memory, SDR has a memory address, and that address will be put inside of P,
Mhm.
which means that we can put P in this printf line and get the same result.
Oh, I didn't expect this. Doesn't P? Don't you need to dereference it to get the value, or in
No,
cases of strings?
because this is declared as a char pointer.
Uh-huh.
If I would like to grab a single character, let's do it like this. If we change this to printing a character instead of a string, and we dereference this P,
Mm-hmm.
then it will print a single character. So when dereferencing, uh, it's like we declared it like this without the star.
Mm-hmm.
When you dereference, it will, in this case, be the same as one single character.
Okay.
But when you send it like, so you're sending the value in this case, the value of that character is being sent to the printf function. When you send it like this, though, we will send the actual memory address to the printf function, which
Okay.
makes it possible to print it in the same way it would with ESTR.
Okay.
We need the S here again, so it's a string. Um, we can do something like this, though. P equals P plus 1. This means we are increasing the pointer, which basically means that the memory address that it used to point to, now it will point to 1 byte further.
Oh, so it's 1 byte.
Yes.
Okay.
So let's say it was pointing to the memory address of 005 or something.
Mm-hmm.
When we run
Yeah,
this
zero, seven.
command, it's going to be pointing to 006 instead,
Mm-hmm.
which is the next position in memory. And if the first position was the capital H, the second position will be this E,
Mm-hmm.
right?
Yes.
So if we compile this piece of code, we'll get hello world
Mm-hmm.
because we start this iteration of the string one character further.
Yeah.
So this means pointers are a great way of iterating through a string, for
Memory.
example. Yeah,
Oh, okay.
because usually when you iterate, you have some kind of index that you are increasing at each iteration of the loop, and you will reference the character like this, right?
Yes.
And that is one possible solution. But you can also use a pointer that you point to the first part of the thing you want to iterate,
Mm-hmm.
and then you simply increase the pointer each time in the loop. And in
Mm-hmm.
that way, you can dereference and go through every character.
Mm-hmm.
And that is how I always
Do it.
iterate strings, for example, or any other structure for that matter.
Mm-hmm. If it would be an array, you'd have to increase it by the size of the element that is found inside the array.
No, you don't need to worry about that. C will take care of this. So in this case, we are dealing with a char pointer, and a char
So
is
it's one
always
byte.
byte.
Yeah.
And that means when we add 1 to this pointer, it will increase by 1 byte. But
Yes.
let's say we create an int pointer.
So you also have to declare. Okay. So you also have to declare what kind of value will be in the memory pointed from this pointer, something like that.
Exactly. Yeah.
Okay.
Let's set this integer to 9,000. And now we can point our eye towards this.
Hmm.
Uh, let's just print it for now. And let's see, in this case, we need to dereference it. Mhm. Right. We probably need to do, let's see, let's point from integer of different size. Let's do this. Okay, it works.
Hmm.
It complained because when you're dealing with integers instead of arrays or strings, as I mentioned before, and you too, it will send the value here, right?
Yeah. So you need to set the memory address, not the value.
Exactly. So that's why we
Okay.
add the ampersand.
Ampersand. Yes.
But if we were to do I equals I plus 1,
Hmm.
in this case, the pointer, let's say we have the integer's memory address is 000 10, for example. And we do this command, which increases it by 1. The memory address stored inside of the pointer will change to this.
Yeah. Okay. Automatically.
Yes,
Automatically because it knows that it is an integer pointer.
correct.
Okay.
So this one should be thought of as like 1 unit of this
Yeah.
and not 1 byte.
Okay.
If you, however, want this memory address to point to just the next one, like this, for example,
Hmm.
usually you can do, let's see, I equals something like a temporary char cast. Let's see, we probably need to put this inside of.
You can cast an integer to a character.
You can when you're dealing with pointers. Let's see. It complains a little bit. Let's see. Maybe we need to do it here as well. It's been a while since I dealt with the integer pointers. Let's see. So I equals char I. Maybe like this. Those parentheses is a little bit tricky sometimes. Incompatible. Maybe we can't get rid of that warning, but the program does what we wanted it to. Now
Yeah,
it
I can do
now it's one point
unit.
right.
One
So
one byte. 1 byte, not 1 unit. Right?
one
Or
byte.
1 unit of character. Yeah.
Yeah, exactly. So this is a way that you can, if you want, for example, let's say you are writing to a file and you want to write 1 byte at a time,
Hmm.
and you want to put an integer inside of that file. Then
Hmm.
you can do it like this and repeat 4 times. That's an example, but usually you write bigger chunks than that. But sometimes you are forced to deal with 1 byte at a time.
Hmm.
Let's say, for
Hmm.
example, you are creating your own printf function. then it's very much easier if you deal with 1 byte at a time
Mhm.
when you, for example, go through this format string.
Mhm.
So let's take a look at the real memory addresses. Instead of using %d to get the value of this integer,
Percent P, I think.
exactly, pointer. So let's remove this star because now we want to reference the pointer and the address, not the
Mhm.
value.
Very, yeah.
And let's see, we'll remove this temporarily. Okay, so this is the real memory address of that integer.
Mhm.
And if we were to do this, uh, so let's see, this ended in, okay, it changes the memory. Let's do it like this instead, because there is a security feature in most Linux machines nowadays, which every time you run a program, it will randomize the memory addresses or the
Okay,
start
so you
date.
cannot access.
Uh,
Okay.
that, that is to make it more difficult to exploit, for example, bugs in programs and stuff like
Mhm.
that. But let's just print it before and after. And as you see, it has increased from 8C to 90. So
Mhm.
8C, 8E, 8E, 8F, and then 90.
90. Yes.
So the starting point is 4 bytes further down
Mhm.
the line. And if we do the same with a chart, um, let's remove this, or let's comment it out. And we put this one here instead. Change this to P and P.
Mhm. One
Here,
byte.
yeah, 1 byte exactly. So that is basically the general idea about how pointers work. I
Mhm.
will do an example what you may use it for in the wild. Let's say we have, okay, well, I'm not going to delete this. Let's create a new file instead. So, ah, redo, 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 two. Annoying. But you get the idea, right?
Yes.
Do you want me to rewrite everything?
No.
Okay. Let's go into pointers 2 instead and include, let's see, CIO, and I don't remember where the function I'm looking for is located. So I will do the man trick.
Man 3.
Yeah, it's called to upper. Okay, ctype.h.
Mhm.
And as we can see, this to upper takes one
It's
argument,
integer.
yeah, or a number, or actually it takes a character, but they have defined it as an integer. I'm not sure why. Perhaps because it should be able to handle like
Like
other
the ASCII
languages.
value, maybe?
And yeah, ASCII values, but ASCII values would have fit inside of a char because ASCII is only between 0 and 255.
Mhm.
But perhaps it will be able to deal with Chinese characters or something like that, which takes more than 1 byte each.
Mhm.
I think that is why. But you can think of this as a char.
So
and
it will
then
actually take a char.
yes,
Mm.
and it will return the char basically. It will when we use it with English characters and yeah operators and stuff.
Okay.
We it will always return a number between 0 and 255, so we can use it as a char.
Okay.
So let's include that file. Uh,
Type.h.
was it like this?
Mm-hmm.
My memory is a little bit slow today. So let's see.
Mail does not work.
First, let's try the function out. We will create a char, which we call C, a regular char, and let's create an additional one, which we'll call C2. We'll set C to the big letter J, not the small letter J, and then we will call this function to upper
Upper.
and supply the value of C. So we are sending the value here, which makes
Mm-hmm.
it possible to use a char. And it will also return the char into the C2 variable.
Okay.
And then we can simply print this out like this. And we get the big letter J,
Yes.
right?
Mm-hmm.
But this is only one character. What if we want to transform an entire string? So let's create a string variable, this, and let's put something inside of it using string copy.
You need string.h also.
Yes, I do. Good. And let's remove this for now. Okay, so we have this hello world string inside
Mm.
of
You need
this.
to. Normally,
Sorry?
you'd use a for loop. I think.
Yes, we can use a
And
for loop. Have you been, do you know for loops?
yes.
Okay. Uh, so yes, we can do it like it's usually done in most languages. We declare some kind of let's say n
Mm. Mhm.
integer for the index, and we do for, and we set I equal to 0. We iterate as long as I is less than the string length of str, right?
Mhm.
Um, and we increase, no, not I, it should be n,
And mm.
yeah. And we increase the n by 1. You know the syntax?
Of course, yes.
By 1 each iteration.
Yes.
And let's make this explicit. We can do it in one line, but let's do it in several. So let's have a character. Mm, yeah, let's do that. We set C equal to 2 upper, and we pass the str at value n, right? Right?
Yes.
Um, and then we can put it back inside of the string or possibly another string, whatever we want, like this, for example. This is a little bit more explicit than doing it on one line. Um, so this should iterate through the string and make it all uppercase, unless we forgot something. Yeah, it works.
Mm-hmm.
So that's one way of doing it. Uh, but there is another way. Let's create a pointer, and I don't think we need this C anymore. Let's rewrite this for loop because strings in C they always look like this, for example. So in our case, we have the hello world, but then we have an invisible
Zero
zero.
byte. Yeah,
Yeah,
I've seen. So you use a while loop until you find the zero byte to iterate.
exactly. And that is perfect for pointers because then we can do for, and instead of assigning a zero to an index variable, we will simply set p equal to the str. So it will point to the first character in this string, right?
Yes. Mm-hmm.
And we want to iterate as long as p, the reference, this
It's not
means
zero
a
byte.
single character, is not zero. So you can just put it like this. Because
Okay.
if you just put the variable, this will be the same as,
Yes, I know. It will come up as false when it encounters the zero byte.
yeah, exactly. And then we can just increase the pointer instead.
Mm-hmm.
And then we can say whatever p is pointing to, or p will be equal to the two upper of the current
Okay.
character that it is pointing to.
Mhm. Understood. So you can also write the for loop like that without the bracers. Yeah.
Yes, if we have only one command
Online.
associated with
Okay.
it.
Like the if statement. Okay.
Yeah, exactly. And
Mhm.
I usually it's not recommended to use this style because it might get confusing, they say. But I think this creates much cleaner code.
Mhm.
Uh, so I don't consider it wrong,
Okay.
as long as you are very
And then
careful with the indentation.
uh,
But nowadays, if you forget the indentation, for example, and do this, I think GCC will give us a warning about it. No, not in this case.
yeah.
But
Okay.
sometimes it does. It does. It says this might not be what you are wanting, for example.
Okay. Yeah, okay.
So that is one way you can use the pointers.
Okay.
And you can iterate through everything. It doesn't have to be a string array. It can be an int array. It can be an array of structures. It can be a
Yeah,
binary tree, whatever.
uh, as long as you have the condition where it stops,
Exactly.
right? Yeah.
And I think we'll stop there. If we go further, that would be the dynamic memory allocation. And I want to have a whole lesson about that next time.